Hello friends, welcome in this series of videos in which we are solving the problems related to transactions and schedules. So today we'll see another problem. So this is a problem. So in this problem, what is the ask is we need to create a graph. We need to create a wait for graph for the above schedule or for the above transaction list. So these are the resources. I have three resources in my operating system which are X, Y and Z, and these are the transactions trying to access them. So I need to first find out that first find out the wait for graph, and then probably there could be a follow-up question that whether there is a deadlock or whether there is a cycle or something like that, right? So that is a pretty theoretical question. So first I'll teach you how to make a wait for graph. So initially we will make three resources. So resources generally we identify with a rectangular box. So I have three resources X, Y and Z. Yeah. So these are the three resources. Now we'll identify the transactions. We can represent transactions as it is. So we'll start with transaction T1. So transaction T1 has a lock on resource X and it requires resource Y. So that is what is being asked, right? So if I go from the resources perspective, resource X is with T1. So I'll make an edge like this. Resource X is assigned to T1 and T1 is requiring or waiting on Y. So T1 is waiting on resource Y. That means T1 requires a lock on Y. Now we'll move to transaction 2. So transaction 2 has two locks assigned to it, which is Y and Z, and it requires X. Okay. So let's first design T2. So Z and Y both resources are currently assigned to T2, and T2 also requires an X resource. So this is the graph for it. It is very simple. Now T3. So transaction T3 does not have any locks and it requires all of them. Right. So this diagram would be pretty much mess over here. So I'll represent T3 over here. It requires X, it requires Z, and it requires Y also. Right. So yeah, in case if you want to represent it more clearly, we can do that also. Okay. So anyways, the solution for this is this graph, and this is the correct solution. We can represent it linearly so that there is no overlap of edges over here. So T3 is a transaction which requires all of them, right? So we'll represent it separately, and T2 requires probably T2 has Y and Z and requires X. So something like this. Again, it is going to have a messy diagram. 32 requires X. Anyways, you can refer to this diagram itself. This is a perfectly fine diagram. So this is how you create a wait for a graph. You are using the transaction and the given resources. Probably a follow-up question would be to find out that if there is a deadlock of resources or any, and what would be the execution. Yeah, so that is a very again important thing, that what would be the order in which the locks would be released. So let's say T1 requires Y, T3 also requires Y, and something like that, right? So we can anyways talk about it, and in some another video, so in which we'll identify that whether there is a cycle in graph or not. So in this you can clearly see that there is a cycle, but what about deadlock and all that? How to detect that if there is a deadlock in the system or not? We'll see in another example. But the ask for this question was to create a wait for graph. So this is the wait for graph for this problem. So thank you so much for watching. In case if you have any doubts, comment it down. I'll try to solve them. Do not forget to like and subscribe to the channel for such content. Thank you.